I'm just kind of waiting for when her next round starts. So
Good. Well, I'm glad she's back home.
yeah,
Good to know.
it's always so much easier when she is. So
Yeah. All right. I see we're doing trig limits here.
yep, it's day before test day.
All right.
I know Miss Brabrand said this test will take anywhere from 15 minutes to the whole period. Just depends on how well you know it.
Got it. Well, hopefully it'll be closer to 15 minutes, but you should take extra time to just make sure, double check.
I mean,
So
even
are
if
we
I
good
finish
with
it in 15 minutes, I still want to double check it a few times. So
right. Are we good with this stuff? Do you know?
yeah.
Do you understand what this means? I'll just real quick explain it to you the way I think about it.
All right.
The limit as x goes to infinity. I always like to just jump on the graph and pretend like I'm doing a trace function where I'm going, like if I'm going x goes to the right, my graph is going to be following down, right?
Yeah.
Does that make sense? So what's
Yep.
the limit? What would you expect the value to be as x gets bigger and bigger and bigger? Well, you'd
Negative
expect
infinity.
the y value. Yep, you expect the y value to be bigger and bigger negative, so negative infinity. Got it? As it goes to the left, I would expect the value to get closer and closer and closer to this asymptote, that horizontal asymptote.
So that's
Perfect,
1.
which is 1. Good. If I jump on the graph at -2, going toward -2, no matter which direction I'm coming from, if I'm coming from the left toward -2 or from the right toward -2, in both cases, I would expect the value to be
0.
0. Perfect. If
And
I'm coming
-1.
Yep, to -1 from the left, that means jump on here. What do I expect the value to be?
You would expect it to be negative infinity.
Good, negative infinity. And if I jump on the graph coming from the right, what would I expect the value to be?
+4.
+4. And notice that it doesn't matter what it actually is. It doesn't matter if this was an open circle or a closed circle. That
Yeah, it
part
only
doesn't matter.
matters for f of x. Like if you're
That's
finding
right.
f of 2, like number 10, that would be 0 opposed to 4.
Perfect. Yep, you got it. F of 2 is 0. Limit does not exist because it's different from the left and the right for -1. The limit as x goes to 2 from the left is the same as the limit from the right, but it's not the same. It's not, which means that value, right, is 4, right?
Yeah.
But since the function value is not the same as the limit, then it is not what we say it is not continuous. It is not a continuous function.
I did have one question though. So
Yeah.
for number 9, why would it? So the one thing that I'm confused on is why would it be the 4 here opposed to D&E, because you also got the 4 down there?
Because the limit doesn't have anything to do with the function value. The limit doesn't have anything to do with the function value. The limit just means what would you expect the value to be as you got closer and closer and closer to it. It doesn't matter what it actually is. What would you expect the value to be? And as long as the limit is the same from the right as it is from the left, then the limit at that point exists.
Okay.
It doesn't matter what the function value is. That function value doesn't have anything to do with it.
Gotcha.
Okay. The fact that this and this aren't the same just means that it's discontinuous at that point. The function is not continuous, and that when you get into calculus, that has a few more implications for you. All right.
So that is
so for
3.
for this one, same kind of thing. We're jumping on here and we're thinking about what's the limit as x goes to 3 from the left. So here's -3. Yep, you'd expect. Nope. What's the limit?
Wait, 3 from the left. Oh, yep. Wait, is that -3 though?
Sorry, you're right. My bad. As x goes to 3 from the left, you would expect it to be. What is that? -2.
Yeah, -2. I cannot count today.
You would expect it to be -2.
All right.
And yeah, it's hard for me to read this, but yeah, that's just a positive 3. What's the limit as x goes to 3 from the right? Again, jump on the graph to the
That'll
right
be a
of negative
-2 as
3.
well.
It's also -2, which means the limit as x goes to 3 is
-2.
-2, even though the function value at 3 is what?
That would be 1.
Good. Now we're doing the limit as x goes to -3 from the left. Here's -3.
That
from
will
the left,
be
and from the
positive
right.
1, 2, 3. Positive 3.
Yep. So what's the function value of at that? So this is positive 3, and this
And
is also
then,
positive
yeah,
3.
all
So
three
this
of
is
them are
positive
+3.
3. But what's the
And
function
then
value?
that would be +1.
Positive 1. And how about at -2 as x goes to -2?
-1, -2, and that is coming from the negative. So that will be 0.
0. And how about coming from the positive?
-1.
Good.
And
And what's the
then it would
function value?
be DNE
I'm
for
sorry, you have
11.
DNE, and what's the function value?
The function value be, wait. What do you mean for the function value?
What's the, I'm so sorry.
Oh, yeah, I
I'm so
was
sorry. I
all
was
right.
thinking this was asking what's f of -1 or -2, but it's not.
-2,
It's
the
saying what's
function
the
value
limit.
is -1. So
You're right, but that's not what it says. I was assuming by the line of questioning that that's what they were going to ask, but it's not. They're asking what's the limit as x goes to 1.
that would be DNE.
That also is DNE. Yeah, without showing all the work for it, you know that it's DNE.
Yeah.
All right, so you know how these, now this is the algebraic limit stuff. Do you know how this works? Do you get this?
Yeah. So you're gonna do this. Oh, well, I can already just looking at it, I already know that this is gonna be 0, so we're gonna have to do some factoring.
Right, we're gonna have to do some simplifying, some
Well,
algebraic manipulations, right?
Yeah.
And the trick for this, if you remember, was to multiply the top and the bottom by
5 minus x plus 2. Well, square root of 5.
root 5
Sorry,
plus root x minus 2. Right, the sign in the middle is what changes, but you're also going to have to multiply the bottom by that, root 5 plus root x minus 2. And then when I do that, this up here, it's going to be 5. It's going to cancel out. This is going to be x minus 2. So in the numerator, you're going to have, so again, it's the limit as x goes to 7 of the numerator is going to be 5 minus x minus 2. Don't forget to put parentheses around that. So you distribute the negative.
Yeah.
Right. And then in the denominator, we're going to have 7 minus x, which is going to cancel out in just a second, plus x minus 2. Don't distribute that in. Now, don't distribute this in is what I mean. But you do have to distribute that negative in. And when you distribute that negative, you're going to get 7 plus, no, 7 minus x.
Yeah,
My
minus
bad.
x. Because you're
7 minus, yeah, because that's going to cancel. That's right. Root 5 plus root x minus 2. That's the limit as x goes to 7. So those cancel out, and you get the limit as x goes to 7 of 1 over root 5 plus root x minus 2. And now I can plug in 7, and I get 1 over 2 root 5, which simplifies to root 5 over 10.
Yeah.
If that's what they want you to write.
Okay. Yeah, she said for this we do not have to simplify it, thankfully, but it's not a big deal either way.
Yeah, some teachers want you to, some don't care. So what do you think you're going to do for number 27?
Minus 6 plus 10. Actually, it looks like you might be able to. No, it's going to be 4 minus square root of 4. So you're going to do the same thing. Well, similar.
Yep. So what am I going to multiply by?
4 plus the square root of x plus 10.
Perfect. Good. When I do that, are you good at it? You want to do it on your own, or do you want me just to run through it real quick?
I'll give it a try. Why not?
Okay.
So the square roots are gonna cancel out here. So it's
Mhm.
gonna be 4 minus x plus 10 in parentheses, and then 4 plus x plus 10 in parentheses, I believe. Because won't the square roots cancel out on the top only?
Well, remember, you're going to first multiply these together. So what is that going to be?
Oh, that will be 4 times 4. That's 16.
Good. So 16.
Oh, so
Now
you're
these are
multiplying
what
it.
cancel out. Yes.
Oh,
Right?
okay.
Because that's what we're doing, right? We're multiplying it.
Yeah.
And so those are going to cancel. These the outside and the inside. This is the outside and this the inside. Those cancel each other out. And then what's this times this?
X plus 10. Oh, just x plus 10.
That's right. And I don't need parentheses. Why in this case?
Because it is a complete function. Because you're
Whoops. I do need parentheses and I
Oh, you
did
do?
that wrong. It should be minus x plus 10. Right? Because
Oh,
this
I
is
see.
going to
Because
be,
4 minus.
that's a negative times a negative. Yeah. Which is, or sorry, negative times a positive,
Yeah.
which is a negative. But
Okay.
then those cancel out. Yep. So I did make that. Almost
Because
made
then
a
you gotta
mistake
distribute the
there.
negative in. And it's gonna be x plus 6. And yeah, the whole square root function.
Yep.
And x
So
minus
this is
6.
going to be limit x goes to 6 of
Let's see. So then you're gonna have.
hold on, you gotta be careful with this one. This is
Oh,
going to be 6 minus x. Now this is a little bit different. Do you know that when whoops, do you know when you have 6 minus x instead of x minus 6? Do you know how to fix that? Do you know what you can
yeah.
do with this thing?
So you're
What do
gonna
I
want to
do?
go ahead and rewrite it. So then it's gonna be
As
negative on the outside and then x minus 6.
perfect, good. Distribute or
And
factor out a -1. Exactly.
yeah. And those are gonna cancel out. So you're gonna be left with -1 on the top
Good.
over 4 plus x, well, square root of x plus 10, x plus 10.
Good.
And it's going to be 4 plus the square root of 16, which is 4. So it's going to be 4 plus 4, which is 8, -1/8.
Perfect. That is the correct answer. Good job. Now, if
All
you
right.
really wanted to check it, you could take a graphing calculator if you have a good one, and you could plug in that top. I'm just going to show you why, kind of another way to think about what this is to give you a picture, which is usually worth 1,000 words, as they say. So if I take that divided by x minus 6, whoops, I'm going to put parentheses around that, divided by x minus 6, and I graph it, and if I zoomed in on it, see what that does? If I
Yeah.
zoomed in on where x, what's the limit as x goes to 6? So I want to zoom in
Yeah.
on that. Now you're not going to see it in the graph. It's not going to show up. If I got exactly there, it would say undefined. But you see how close I am to 6 there? See how it says x equals 5.99999?
Yeah.
And what's that number? Negative 0.1250000. That's like negative 0.125, which is -1/8.
All right. Perfect.
If you clicked on calculate down here at the bottom and you wanted to calculate the value at 6 when x equals 6, it's going to say does not exist.
Oh,
Y equals NaN. I don't know what that stands for. Not a number. I don't
non-existent
even.
number,
Well, it says an
not
A.
actual number.
Maybe. Yeah, I don't know. I've not seen that before. But see how that won't work. But if you go just a little bit to the right of it, 0.00001, that whoops, then it will work. That didn't work. See that? What's that super close to?
0.125.
Negative 0.125, which is 1/8.
Negative 20.
Okay.
Right.
That just shows you. That's another way to look at it, or another way to think about it.
Yeah.
Number
then,
31. What's the trick?
It's gonna be 5/3 because you essentially. Here, let me grab my cursor. You're gonna essentially eliminate that, that, and that, and then in order to get in the parentheses, is just gonna x is gonna turn to x squared.
Good. I don't see what you're doing, but I think what you're saying is correct. You're going to divide.
Yeah,
You're going to
basically
divide.
you double it, right, to go into the fraction.
Yep, you got it.
Yeah.
So that means I have the limit as x goes to infinity of the square root of 5 minus 6 over x squared, all divided by 3 minus 5 over x. And then all of these things just go to 0. That goes to 0, and that goes to 0. I just don't know that you said the right answer to me.
It's
Did you say the
5/3, right?
square root
Oh,
of 5
ooh,
over
yeah,
3?
square root of 5/3. Okay.
Yeah. So the limit would be the square root of 5 over 3.
Could you also check
That would
this
be,
one in your calculator also then?
you could, but it would be harder to, the reason that this would be harder to know is because you're going to have to like plug in, this is as x goes to infinity. So it's not like you can see that number, but you
Okay.
can do it. You can do it if you go, I'll show you what I'm talking about. If you punch in the square root of 5x squared minus 6, 5x squared minus 6. Oh, why is that thing there? Delete that. Okay, that's in the numerator. And then I'm going to divide that by 3x minus 5, 3x minus 5. And now if you graph this, you can see, remember, you're trying to find what the limit is as x goes to infinity. So what you're going to want to do is go all the way to the right, and you can see what it's getting closer to. As I go, see how I'm at 1,000?
Yeah.
The problem is it's hard for you to know what that exact number is. The approximate number is 0.746. That's approximately the number. So it's not like you'll know what that number is. Like it's because this is an irrational number. Square root of 5 is an irrational number.
Yeah.
But if you typed in the square root of 5 divided by 3, you're going to get about that same number.
Okay. So pretty close.
Yeah. The reason that it's not as close is because I'm not as far to the right.
Yeah.
Right. It's getting a little bit lower, a little bit, just slowly, incrementally, slowly. It's getting closer and closer and closer to that number, 0.74535599925. And that is an irrational number. It never ends and never repeats. Okay.
Okay.
So for this one, now they're just asking this to us in a different way. They're saying, if I give you a piecewise function, right? This is a piecewise function. This is the first piece, and this is the second piece. What kind of a graph is this piece?
That'll be 5 minus x.
What kind of a graph is it?
Is it just a linear graph, kind of going like that?
Very good. Yeah, it's linear. You got it. Here, let me grab a blank coordinate plane.
And then the second one's a quadratic.
Very good. So for this one, I'll do this in red. If where x is less than or equal to 2, so let's start at 2. So I'm going to put a point in here. I'm going to start at 2. It would be 2 comma what?
Let's see, 2 comma.
Plug that in. to this part.
Oh, that's how you're doing it. So it's
Yeah.
2 comma 5 minus 2, which is 3.
2 comma 3, so that's 1 point. There's 2 comma 3 on my graph. And then notice this is going to the left. And what's the slope?
Negative. So
Negative
it's a
1.
negative sloping.
So I'm going to go up. I could go up 1 and to the left 1, right?
Yeah.
Or I can go up 3 and to the left
3.
3, right? It's basically the slope is going to be 1. So let's go up 1. Where am I at? 3, 2 comma 3. So if I go up 2, left 2, is that where I'm going to be? And so my graph is going to be like this, and it's going to go to the left from that point. Got it?
Yeah.
And then this graph, like you said, is a what?
Quadratic.
It's a quadratic. And what's the point at 2? 2 comma what?
2 squared is 4. 4 minus 3 is 1.
2 comma 1. Good. Now this is a little bit harder to graph just from some random point.
Oh,
it's
so you
right
start
here.
with an open circle, correct?
And now it's actually a parabola. So what I like to do for these, I like to just graph the parabola. Notice it's x squared minus 3, which means it starts 3 below the x-axis. And it's going to go like this and like this. But so I like to just graph the whole parabola and then erase the part that is to the left of it.
Gotcha.
That makes sense. Or what you also could have done, could have just plotted some other points. Plot the point, plot maybe 2 or 3 more points to the right of it. 3 comma 3 squared is 9. 9 minus 3
6
is 6. So 3 comma 6 would be here. And then 4 comma, what would 4 squared be?
16, 13.
Comma 13. So you see how 4 comma 13. You see how quickly that rises?
Yeah.
So that's what that's doing. That's actually it's hard to tell, but that's actually part of a parabola.
I see it.
Line, but it's not. It's a parabola.
Yeah, I see it. If you had a bigger graph,
saying?
that would be easier to tell. Yeah.
Yeah, exactly. So now the question is, what's the limit as x goes to negative 2 from the left?
That would be 3, I believe, is what we got. Yeah.
Yeah, it's the red thing. And what's the limit as it goes to 2 from the right?
1.
1. And what's the limit?
Does not exist.
Perfect. DNE. You got it. Okay.
I think I wanted to say like DNS at the start. I think what I was saying, like does not solve opposed to does not exist.
Yeah. Yeah, you said, I don't remember what, but you said something.
Something weird.
DNE.
Yeah.
Just DNE.
I don't know why I had so many issues getting that one.
All right.
So do you really need to like graph it necessarily?
No, you don't. But I wanted to
Okay.
give you that visual for you to
Yeah.
understand what we're dealing with here. Yeah. So you don't really even need to graph these. You can literally just plug in the values. You can plug in the values. So this top one here,
So it's going to
the
be a 1
value is
negative
going
1.
to be 1 comma 1 comma 1. Nope, 1 comma negative 1. You're correct. This next one is going to be at
3 comma
1
1.
comma.
I mean
1 comma 3. Whoops.
Yeah.
1 comma 3. And this last one is going to
1
be
squared
at
is 1 comma negative 1 again.
good. And so do you see how this is just a single point. This red one is just a single point.
Yeah. Okay.
So are you good at visualizing what's happening?
Yeah, I can kind of see what's happening. So
See that there's going to be a hole.
yeah.
that there's essentially going to be a hole at 1 comma negative 1, and then the dot is going to be at 1 comma 3. Can you visualize that?
Yeah. So
That's why I like to graph them, is because I don't know how good you are at visualizing it. So for me, I can see right away, I know what's going to happen. Here's 1, and the blue graph is going to be at 1 comma negative 1, and it's going to be going, it's going to have a slope of,
2/3.
it's going to have a slope of
I mean,
2, so it's going to be
yeah,
like
2
something like
over
this.
1.
Yeah, right. And
Yeah.
then the green one, I'll skip the red one for a second. The green one is going to be a parabola at that same point. It's starting at that same point. So it's going to be 1 comma 1, and then it's going to go to the right. So it'll be 2 comma 2, and then it'll be 3 comma 9 minus 2 is 7. That's what you're going to get. So it's going to be a parabola starting here, but not filled in, right?
Yeah.
Filled in because it's still not equal to, but then it'll be at 2, 2, and then at 3, 7. So it's going to be like a parabola. Again, it's hard to tell, but that's a parabola, not a line. Got it? But
Yeah.
then
And
the
then
red one is going to be the actual dot.
yeah, 1,
So
3.
the actual dot is going to be up here. So what's the limit as x goes to 1 from the left?
That's gonna so A, B, and C are all gonna be -1,
Perfect.
and then D is gonna be 3.
Perfect. You got it. Good job. So
All
you
right.
don't have to draw the graph if you don't need to. If you're good at visualizing it, then just visualize it.
Yeah, so
Okay.
I can see that we do have a I see that we got a dot on 32. The rest are gonna be open circles. So for
Uh-huh.
5 times 2, that's gonna be 10. So it's gonna
So
be 2 comma
negative 2,
10.
10.
Yeah, -2, sorry.
Yep.
And
And
then
this is negative 2.
3 minus 2, that's gonna be 3 times -2, -6 minus 1, -7.
Good. And what's the last one?
Let's see, 2 squared is that 8, right? So it's gonna be -8.
Good. Now, is there going to be, well, what are the answers?
So from for A it's gonna be so it's 2 from the negative, that would be 10.
Good. Whoops. Meant to make
And
that blue.
then from the positive, that's -8
Good.
for B. And then C is does not exist.
Perfect.
And then for D is -7.
You got it. Okay. Makes sense? How
Yeah.
that works?
All right.
All right. What are we going to do with this one?
So you got x squared minus x minus 12. So then 3 squared is going to be 9 minus 3. That is gonna actually work.
Is it going to be
What's
0
that?
over 0?
Wait. 9 minus -3, so 9 plus 3.
Is 12.
Yeah.
Which tells you that this is going to factor into x plus 3 times something, right?
Yeah, x plus 3 and then x minus 4
Good. So now what happens?
over x plus 3. So then the x plus 3 is cancel out. So it's going to be -3 minus 4, which is -7.
How about the next one?
All right. And then that's going to be 3 squared, which is 9 minus 9. So you're going to have to factor this one again.
Mm-hmm. And you know, one of the factors has got to be x minus 3 on the top and the bottom, right?
Yeah.
Because that's going to cancel out. And that's why you got 0 over 0. The only way that you would have gotten 0 over 0. So this
Yeah.
up here, it's x plus 3. And down here, it's that SOAP thing.
Oh, right. It's going to be x
This
squared.
is the same.
Same
This is
opposite,
the
always positive.
opposite.
So it's a plus.
This is always positive. Yep. So it's x squared, 3x, and 9.
Yeah. It's plus
Right.
between the x squared and
Thank you. So then what happens?
So you're going to go ahead and plug it in. So it's going to be 3 plus 3, which is 6 over 3 squared is 9 plus 6 plus 9. So it's going to be 18, 24.
Which equals 1/4.
So in this, you can still simplify, right?
Yeah.
Okay.
Yeah. When you're done, when you're all done, for sure you want to simplify.
Okay. Oh, well, this one is going to be -1 minus 1, which is -2 over 0. So is that a DNE? Believe?
Mhm. Yeah. So this one, if you didn't do that first, if you just factored it and canceled, it'd be x plus 1, x minus 1, and this would cancel out, and you get 1 over x plus 1, and you're allowed to plug in -1 there.
And that's 0. So
Negative, yeah. If you plug in -1, you'll get 1 over 0. So you remember what this is?
does
Remember
not
how
exist.
this is? Do you remember how this is a?
Yeah.
This means that there's a vertical asymptote at -1.
Yeah, and then
Remember
RD.
doing that?
Yeah.
And well, there's not really an RD here. There's a. It's not a removable discontinuity. This is a vertical asymptote. So your graph is going to be, like this.
Okay. Yeah.
But you have a vertical asymptote. So what is the limit? It does not exist. Yeah, because you had 1 over 0, but you could have also told that, but when you, like you did at the beginning, plugging it in, you'll get -2 over 0, not 0 over 0.
Oh yeah, -2. Sorry. Did I say 0 over 0 or?
No. You said it right. You said
Okay.
it right. You said does not exist. I was just, again, I was explaining it further to help you
Gotcha.
process that, understand. All right, how about these ones? What do we do? Do you have a stylus that you can try it on your own or no?
I got a mouse. I can try it out.
Well, you can
So
just do it on a piece of paper if you want, but I want to see you try it. I want to see you see if you can get.
all right. So you get 1 over -1 plus 2, which is gonna be 1 over -1, which is gonna be wait. No, 1 over 1, which is 1. So it's gonna be 0 over 0. So for this one, I believe what you're gonna want to do is you're gonna want to go ahead and I forget what the name of the rule is, but you're gonna want to do 1 over x plus 2 minus plus 1 on the top and the bottom. I believe
I wouldn't do that. That's the conjugate. What I would do is multiply the entire top and the bottom by the least common denominator, which is x plus 2.
Oh,
And here's why. Because then when you do that, this multiplied here, what happens to the x plus 2?
they cancel out.
It cancels. This multiplied here, what happens?
It is going to be
You get
negative x plus 2.
minus x plus 2.
Yeah.
Don't forget to keep it there. And then in the denominator, you just have x plus 1. Don't distribute, just leave it like this, times x plus 2. And remember, this is the limit as x goes to -1 of all that. Now
Okay.
this simplifies to what on the top? How does that simplify?
Wait, would it be x minus or would it just be 1 for this?
My bad.
Like for
You're
the
right.
first
It
one.
would just be 1. Good job.
Okay.
My bad.
Yeah, I was like,
But,
I don't think you can get an x from that, so I was trying to figure out where you.
Yeah,
All right.
no, you did that right. Yep. You were correct.
So
and what does that simplify to?
you're gonna want to distribute the negative in there. So it's gonna
Uh-huh.
be negative
Negative.
x minus 3. No,
Careful.
minus 1.
Minus 1. Good. Which again, what can I do with that? What can I take
You
out?
can you can take out the negative. So it's going to be x plus 1.
Good job. And you know that's got to happen, right?
Yeah, so it's going to be
You
x
know
plus
this
1 over
somehow
x.
has to, you know it has to cancel out. You know there has to be a factor of, look up here at the top again. You know, since you had 0 over 0, you know somehow you can rewrite it so that there's an x plus 1 on the top and the bottom.
Yeah.
Okay. And that's what you just did. You just rewrote it. So there's an x plus 1 on the top and the bottom.
So it's going to be
Right.
-1 plus 2, which is uno.
And don't forget it's
Oh, wait.
-1 on the top still.
-1 over
Negative
1.
one
So
on the
it's
top
negative,
over
never negative uno.
1, which equals -1. Good.
Mm-hmm.
What factor am I going to have in the top and the bottom of this one?
Is it going to be
Look at
x
this. It'll
minus?
tell you.
Oh, x plus 1.
Nope, you were right. X
X minus 1. Okay.
Yep. There's going to be an x minus 1 on the top and the bottom if it's 0 over 0, which I'm assuming it is 0 over 0. So then I know that this has to be x plus 2, right?
Yeah, and then
And
the
I know
bottom
that
one is x minus 2.
gone.
And that's going to be x plus 2 over x minus 2, which will work.
What do I get?
You're going to get 3 over -1. So it's going to be -3.
Perfect. And how about this number 19? What am I going to do? What's the trick?
You're going to want to take the x plus 2. I mean, x plus 8 out. So you're going to take out the least common denominator. No.
Good. Yep.
And then are you
Which
going
is
to
what?
also want to do the same thing for the 8?
Yep. You have to multiply it by the least common denominator, which is 8 and x plus 8.
On both the top and the bottom.
Good. And when I do that, I'll do the color coding again. When I multiply this in here, what do I get? Out.
You're gonna get 8 and then x plus 8.
And the x plus 8s cancel out.
Yeah.
And when I multiply this in here, it cancels out.
Yeah. So you're just gonna
The
be
eight,
left
the
with
eights,
x
the eights cancel out, right?
plus 8. Yeah.
But don't forget that parentheses. Always keep the parentheses.
And it's all over 8.
All over x times 8 times x plus 8. And it's the limit as x goes to 0 of that whole mess. And now, how does that top part simplify?
Let's see, so now it's gonna be negative x. It's just gonna be negative x
Good.
minus 0. So
and then 8x times x plus 8. And what cancels out?
would the x cancel out? The x's?
Yeah. And what am I going to be left with?
You're gonna be left with -1 over 8, and then x plus 8.
Now what can you do?
Go ahead and plug in the 0. So
And
it's
what
gonna
do I get?
be -1 over 8 times 8, which is 16. So -1/16.
Nope, 64.
Oh wait, 8 times 8 is 64.
Yeah.
I need to be careful there.
Yep. Be careful.
Simple multiplication can't get me on a test.
If you have the extra time,
we're not allowed to use our calculators on this, but on the final.
Oh, okay.
So
all right. No problem.
Trust me,
Okay,
I wish that we were able to use our calculators on this. Yeah.
Yeah. All right. How about number 20? What's the limit as x goes to infinity?
0.
Perfect.
And then for 21, it's going to be
that whole thing is going to 0. So this one, again, you're just you can do that one trick if you want. You're right. It's -2/3. You could think of it, there's a couple ways you can think of it. You can think of this as the rational function, and you know that the asymptote is at the horizontal asymptote is going to be at y equals -2/3. Or so you could do it that way, the old-fashioned graphical way of envisioning it. Or you could just divide everything by x, and you get 4/x plus 2 all over 4/x minus 3. And all of these things
Yeah, those
go
both
to 0.
go to 0,
And all you're left with is 2 over -3.
which is 2/3. Well, negative
Yeah,
2/3.
this is -2/3. And the same thing with this other one. You could do that same thing. Or you could just realize, oh, wait a minute, this is top heavy.
So
Yeah,
it
it's x
does
cubed.
not exist.
So that means it does not have a horizontal asymptote, and therefore it doesn't exist. Now, do they want you to write positive infinity or negative infinity, or are they okay with the any?
So for this one, she would want us to write the infinity. It's kind of weird.
Right.
So for these
so
ones,
make
she wants us to, but the other ones she wants us to just write does not exist.
right. So make
That's
sure that you
so
know if it's a positive or negative infinity.
in this case, I believe it will be you're going negative infinity.
You're going to positive infinity, I
Oh,
think,
wait.
aren't you?
Yeah. Sorry. So it's actually going to be positive infinity.
I believe it is positive. So I don't know how she taught you to do that, but what I do is I do
Just
that
plug
trick
in
where I
random
divide it.
positive number.
I divide it. You could do that, or I just divide everything by x squared, because that's besides the denominator, that's the biggest one.
Yeah.
Actually, you can divide everything by x cubed. Will that work? If I divide everything by x cubed,
Everything will just go to 0,
no.
except for the 5.
Oh, yep. Nope, I can't do that because then I'll have 0 in the denominator. Yeah, that's why I was doing x squared. Divide everything by x squared.
Oh, right, because it's in the only denominator only.
Yeah, so that's 5x minus 12 over x squared, all divided by 4 plus 7 over x. And so these things all go to 0. So you've got 5x over 4. And what happens to this as x gets bigger? What
It
happens to this
goes
as
positive.
x gets bigger? Yeah, it goes positive.
Okay.
So I think you just look at the leading coefficients essentially is what they might teach you to do.
Yeah.
All right, what about for this one?
All right. So 6 plus, so this one will not work. So you're gonna want to do you're going to do 4 plus square root of x plus 10 on the top and the bottom.
Good. And what do I get?
It's gonna be.
Did we do this one already?
Hang on, we might have actually.
Feels like we just did it. It's okay. Just do it again.
All right. Yeah, sorry, I
tell
was
me what
just
to do.
copying it in, so I might have accidentally done a few duplicates. But
That's okay.
oh, it's gonna be 8
No,
minus.
don't do that. Don't
wait.
do that.
Oh wait, those just cancel out.
Nope.
I mean, oh, 16.
What's 4?
Ugh.
Yeah. Don't do 8. You've done that a couple times. Don't make that silly mistake. Okay.
I need to like write myself a note. Slow down
Yeah.
on multiplication.
Yes. Slow down on multiplication.
All right.
16.
16
then what?
minus x plus 10.
Good. And don't forget to have that in parentheses. All over
X plus
minus
6
6.
and then parentheses, all that. Yeah. And then
This just equals 6 minus x, right?
yeah.
which equals what?
That will be negative x
Negative.
plus 6. I mean x minus
Mm,
6. Sorry.
yeah, negative x minus 6.
And that
So now
cancels
I can
out.
cancel
So you're
out.
gonna be left with -1 over all of that. Well, all of that specifically.
Uh-huh.
And then it's gonna
And what's
be
that equal?
-6 plus, it's gonna be 4 plus 4, which is 8, so -1/8.
Yep.
Yeah, we did do that one.
Yeah. How about next? 28.
I don't think we've done this one.
Uh-uh.
So this, shouldn't I distribute the squared? Like the square,
Not really
because
distribute it.
what?
It's not really distributing it. You should multiply it out.
Yeah, multiply it out, sorry.
You can't distribute it, right? You can't just
Yeah.
say x squared plus
Sorry.
4. You know that, right?
Oh, you can't? Oh.
No,
Well, that's what I was gonna do,
no.
actually. Sorry.
That's what I was afraid of.
Oh, so
This
you're gonna
does
want to take
not.
the square root of the top and the bottom?
Nope. What does x plus 2 squared mean?
Oh, x plus 2 and x plus 2. X
Yeah,
plus 2 times x plus 2.
you can't just distribute that. That doesn't work. You have to FOIL it out. It's x squared plus 4x plus 4.
Yeah, it would have gotten me there.
Yeah.
All right.
So that's like one of the top mistakes for kids in algebra 2 pre-calc.
Oh wait, it's I can see right now it's gonna be bottom heavy, which means it's 0.
Yeah. That's right.
Because it's gonna be 2x
So you might
over
even
x
have
squared.
been able to tell right before even doing that. You might even have been able to tell that.
Yeah, I see where. I mean, I would have gotten the same answer, not the right way, but that could get me in
Correct.
other
You would.
places.
You're right. You would have gotten lucky on that one. You would have. So 2x all over x squared plus 4x plus 4, which just means that the limit equals 0 because that what you just said. Good.
All right, last slide. So it is gonna be. Oh, this one's actually gonna work. So
How
it's gonna
about that?
be 2 minus 5. It's gonna be -3 over 2. -3 halves.
Good. Yeah, don't waste your time if you don't need to do anything but plug it in. Good.
Yeah. 3 plus
How about for number
3.
30?
So in the top, it actually will work. Because it's gonna be 2/3 minus 1/3. No, you gotta do this.
3, 6.
Yeah,
Nope, it's 1/3 minus
yeah,
1/3. 2, 6 minus
yeah.
1/3,
You
which is, yeah, is
you
0
gotta
over
do
0.
this. Yeah, you gotta do I take the LCD of both of
Good.
them. It's just gonna be x plus 3.
And
And
what?
3.
Good. And when I do that,
You're gonna
what
do
happens when I
2
multiply that
times
there?
3, so it's gonna be 6
Good. And what happens when I multiply
minus x plus 3.
minus
Parentheses
x
x plus
plus
3.
3 all over? Don't
And
forget, you
then
also had to multiply that in the bottom. I
yeah, it's
forgot to
just gonna
write
be
that.
all over
So it's
all
3
over
times x minus 3 times x plus 3. And then this simplifies to what?
x, no, negative x minus 3.
Yeah, or 3 minus x, which also simplifies to what?
Negative parentheses x plus 3.
X minus 3. Nope, just switch them. It's still a minus. Just switch them.
Oh, right, because it's positive 3. Okay.
Yeah.
All right. And then the x minus 3s are going to cancel.
Good.
So you're going to be left with -1 over 3 times x plus 3. So it's going to be 3 times 6, which is 18. So it's going to be -1/18.
Good. So remember this little thing, because you've done that a couple times too. Don't forget that you have to, when you flip it, you still keep the negative in between it, but you put the sign on the outside. It's like factoring out a -1. Think of it like this. What's 5 minus 3? What's 5 minus 3?
2.
2. And what's 3 minus 5?
3 minus 5 is going to be -2.
See how they're just opposites of each other?
Oh, yeah.
Okay. So when we have something like 3 minus x, you can switch it to x minus 3, but it's going to be the opposite of that. So when you flip them, if you're having subtracting things, you can't just flip the order unless you make it negative. You can flip the order as long as you also make it a negative. Another way to think of it is factoring out that -1. Okay,
Gotcha.
you're factoring a -1 out of this. Essentially, you're taking a negative out of the 3, which makes it now a -3, and you're taking negative out of the x, which makes it a positive x. Right?
Yeah.
That's really what you're doing. But kind of a different way to think of it is just swap the two numbers, but then also put a negative out front of it. Swap the two numbers, like switch their position, keep the negative in the middle, but put a negative out in front of it, because that's what you're basically doing.
Okay.
Good.
Yeah. I think so. See, I'm feeling
I
good
think
for my test tomorrow.
I think you're gonna do great. I don't think you have anything to worry about.
Yeah, I'll just do my usual, watch this in the morning again, kind of go through it before school starts.
Perfect.
That's what I've honestly been doing. Like, I sit out in the hallway and I just go through it until class starts pretty much.
Good. That was my intention.